All right, so today's objective is the same as yesterday. You're going to solve quadratics by factoring. So factoring is what we spent all of Module 8 doing. I did finish grading this class for Module 8 test, so you might have seen that last night. But it's something that we've already learned, so hopefully it's a bit of review. The only added thing that we're doing is setting the quadratic equation equal to 0, and then factoring it and setting each factor equal to 0 and solving for x. So here's some videos to help you with that I did not make. The class lecture will be posted later and you can find it here. And also today we're going to be reviewing the slide and divide method, which I think would be beneficial because about I would say 50% of you got it right on the test. So that's a good one to review. You do have a practice today that you picked up on the back table. I already wrote the title on it for you, and just evens or odds. All right, don't overwork yourself by doing the whole thing unless you feel like you need the extra practice. But otherwise, just evens or odds, and that should give you enough exposure to all the kinds of problems you could potentially see. We don't have any assessments coming up soon, but just so that you're aware, the deadline for late work from the orange folders in Schoology is going to be April 9th. So still a ways away, just make sure we're staying on top of all of our late work. Questions about any of that? All right, so we're going to start with the day 1. So the steps are going to be the same for both day 1 and day 2. You're going to solve by factoring. Eva, is it a question about this? Wait a second. So you're going to solve quadratics by factoring by setting it equal to 0, factoring one side, and then setting each factor to 0 and solving for x. So we already did a lot of examples yesterday. What we didn't really get to is down here. So equations not in standard form. This is from day 1. All right, so equations that are in standard form. So I would write this over here. Equations that are in standard form look like this. So ax squared plus bx plus c. All right, if you were absent yesterday, hopefully this looks familiar from when we did it before spring break. From before spring break, because we learned how to factor stuff in that format. So these are the standard forms of quadratic equations, though. If it's not in this format, like if it's like number 17, where there's stuff on both sides of the equal sign, then all you have to do is move it. All right, we've done that before, but we probably just need to refresh our memory. So in number 17, it's not in standard form because the 21 is on the wrong side of the equal sign. We need to move it to the other side. How can I get the right side to become 0? Do the opposite. So what would I do? Good. If I subtract 21 on the right side, that gets it to equal 0, which is what we want. That's what the step 1 is for factoring quadratics. So to maintain equality, what you do to one side of the equation, you have to do to the other. So on this side of the equation, I need to also subtract 21. So the right side cancels out, and we need to put it on the left side. Now, is there a like term that I can combine that 21 with on the left side? No, there's not. There's not another constant that I can combine it with. So this one's a little easier, because when there's no like terms to combine it with, I just kind of insert it on this side. All right, since we have to subtract it in order to get it to equal 0, it's going to be minus in the equation. Not necessarily. It should match up with standard form. So if you didn't hear that question, Ian asked, will it always be at the end? Not really, it just depends. Is it an x squared? Is it an x? Or is it a constant? All right. So from here, though, it's just like how we did yesterday. You would just keep factoring it. Any questions so far? So how can I factor this left side of the equation? What method can I use? Good. I'll write it over here. So set up your diamond. We have negative 21 on the top and 4 on the bottom. What are two numbers that multiply to negative 21 but add to 4?
3. Negative 7.
7 and negative 3.
All right, so let's try it like this. Does it work for the whole diamond? Yes, so I would agree that the negative does go on the 3. So just try it out. If it goes on the 7, you would have seen that it would have added to a negative 4, and it should be positive. All right, so right now what we have for our factors is x plus 7 times x minus 3 equal to 0. So we factored this. Now, following the steps from the front side of the page, we're going to set each factor equal to 0. So factors are things that you multiply together. So this parenthesis times that parenthesis. So what I'm going to do is take each one and set it equal to 0. So x plus 7 equals 0 and x minus 3 equals 0. What value of x plus 7 equals 0?
Negative 7.
Good. So negative 7 plus 7 equals 0. So the negative 7 is part of my answer. What value of x here will make this true?
Positive 3.
A positive 3. So then when you write your answer, it should look like this with those curly braces. All right, so my x values were negative 7 and 3. All right, questions about that? All right, I'll save the you try for the when you guys do your practice, because I kind of want to make this, I want to give you time for your practice. So if there's no questions, we'll try 20 next. All right, so for number 20, we have a little more things to move. And you could decide to move things in any direction. It doesn't always have to be to the left side. Just do whatever's easier. Since in number 20, this side is shorter than this side, I'm probably going to move stuff over here. But I have to do that by basically doing the opposite of what's being done so that I can get one side equal to 0. So I'll just move things like one at a time. How can I get rid of this 1? Good. So to get that to cancel out, I would subtract 1, and what you do on one side, you have to do to the other. And match it up with your like terms. All right, so constants go with constants. Also in this same step, I'm gonna get rid of this 4x. How can I get rid of it? Good. So we're going to subtract 4x from each side. If you're wondering why I subtracted, well, that's how I get it to cancel on the right side. Does that make sense? So then on the right side, 4x minus 4x is 0. 1 minus 1 is 0. So on the right side of the equal sign, I have a 0. On the left side, I need to combine like terms. So the x squared doesn't have any partners to combine with. There's no other x squared to combine with. What can I combine the negative 4x with?
Negative 16.
The negative 10x. So then what's negative 10 minus 4?
Negative 14.
Good. So when you combine like terms, you combine the coefficients, you leave the variable part the same. So minus 14x. And then you can combine the 49 and the minus 1. What's 49 minus 1?
48.
And it's positive, so put plus 48. All right, so everyone see how we just rearranged it? All right, and then you would continue factoring like how we did yesterday. Do you want to take a minute and just factor this out real quick? All right, on your own paper, factor this out from here. See if we get the same answer. Set up your diamond. All right, for number 20, what numbers did you pick that multiply to 48 that add to negative 14? All right, any disagreements? Does this work for the whole diamond? Yes. So good job, you found your factors. And then to solve the quadratic, you set each factor equal to 0 and then solve for x from there. All right, but I'm a little out of room. What did you get for your final answer? Good. All right, and then check your answer when I plug in 6. Is 6 minus 6 0? Yes. When I plug in 8, is 8 minus 8 0? Yes, so we're done there. All right, so good on the day 1 part. All right. Now we'll try some on day 2, and we'll just kind of keep it short and sweet. There's really only 2 types of problems on day 2 that you'll see. So for the day 2 notes, looks like this. We're looking at quadratics where the leading coefficient is not 1. So like this one's in standard form and everything, but we can't just jump into the diamond method because leading coefficient is not 1. So what are some other methods that I can use when the leading coefficient isn't 1? There's 2 of them.
Yeah,
Slide and divide. Anyone know what the other one is? Good. All right, I suggest always checking for the GCF first, because that can usually make your life a little easier. But slide and divide is like a good backup. It's just a lot of people forget the divide part. All right, and that's what I saw on the test too. I feel like about 50% of people got the slide and divide question wrong. All right, so looking at example 1, can I use, I definitely can use slide and divide, but can I factor out a GCF?
Oh, yeah.
Yes, example 1 does have a GCF. So I'm going to factor it out because usually that'll make life a little easier if you do that. So the GCF is 3. So divide that from each term. 3 divides evenly into all of them. Make sure your GCF goes outside the parentheses. And then inside is what you get from dividing. So it's 3x squared divided by 3. X squared, good, because the 3's cancel. What's 9x divided by 3?
3x.
And it's positive, so put plus 3x. And then what's negative 12 divided by 3? Good. Now, the inside of the parentheses, could that be factored more? Well, in that case, I would have 3 equal to 0, and then this whole thing over here equal to 0. So usually for these problems, if they say solve it by factoring, you can usually factor this a little more. Anyone know how we can factor the inside? You would do the method.
S equals 0.
So ignore the GCF right now.
Oh, you do the diamond.
You can use the diamond method for what's inside the parentheses. So then set up your diamond. We have -4 on top and 3 on the bottom. What numbers will you pick for your diamond? All right, 4 times -1 is -4. 4 plus -1 is +3, so good job there. So our parentheses become x plus 4 times x minus 1. Bring down your GCF, and then the equals 0. All right, so we factored the left side completely. Now we continue with the rest of the steps, which are to set each factor equal to 0. How many factors do I have?
2, 3.
I do have 3 factors. All right, because factors are things that you multiply together. So we do multiply that GCF here. All right, so set them all equal to 0. We get 3 equals 0, x plus 4 equals 0, and x minus 1 equals 0. Now, does the 3 equal 0 make any sense? It does not make any sense. So we're only going to have 2 x's. We can never have 3 x's. So that's just kind of there. What's going to be the value for x in the middle? Good. And what's going to be the value for x on the right side? Good. So then when we write our final answer, we get -4, 1. All right, questions about that one? All right, I'll have you guys try number 1 on the you try section. So try number 1 on the you try section. All right, so if you did it correctly, your final answer should have been -4 and -1. So you could have solved it by slide and divide too, but GCF might have been a little easier, fewer steps involved. So 2 can be divided evenly into both, so that's what's shown here. And then you can factor the parentheses using the diamond method. So 2 numbers that multiply to 4 but add to 5 are going to be a +4 and a +1. All right, set each factor equal to 0. 2 equal to 0 doesn't make any sense. The middle one, -4 plus 4 gives me 0, and -1 plus 1 gives me 0. So that's why those are my final answers. All right, makes sense? Any questions?
Were we supposed to do the day 1 yesterday?
No, I've given you time today. So you'll have time today. All right, but over here, we're going to do an example for slide and divide. So that's going to be example 3. So always check for a GCF because that's usually easier than sliding and dividing. But sometimes you don't have a GCF. Like, does example 3 have a GCF? No, it does not. there's not a number that goes into 2, 3, and 5 evenly. So in that case, we have to use the slide and divide method. We don't have another choice. So then slide that first number over to the last number and multiply it. What's 2 times -5? Good. Bring everything else down. So my new quadratic is x squared plus 3x minus 10 equals 0. Now, this is something we can factor using the diamond method. So set up your diamond. What numbers multiply to -10 but add to 3? And which one has to be negative? Good. So then x plus 5 times x plus 2, or sorry, x minus 2 equals 0. Now, can I just finish here and set them equal to 0 and be done? No, what did I forget to do? The divide part of the slide and divide. So we slid, we did not divide. So what do I divide by? Good, always divide by what you slided. Reduce these fractions as much as you can, but you will have to end up sliding one of them in front of the variable. It's kind of like slide and divide and then slide again. All right, so 5/2 cannot be reduced anymore.
So you have to add it.
Other than like a decimal, you don't want a decimal.
So x plus 5.
So we move the 2 in front of the variable and it becomes 2x plus 5. Over here, can the -2/2 be reduced?
Yeah.
What does it become? -1. Now that's how when we FOIL, we get what we originally had by sliding that denominator in front of the x. All right, so clear how we got this far?
Yeah.
All right, so that's just reviewing, sliding, and dividing. Now we're going to solve the quadratic. So set each one equal to 0. Now we have 2x plus 5 equals 0, and x minus 1 equals 0. Let's start with the easier one. What's going to be the value of x over here? 1. Because 1 minus 1 is 0. Now over here, it's a little bit longer, but you should still know how to do it from first semester, so let's refresh our memory. When solving for x, am I going to get rid of the 2 first or the 5 first? You want x completely by itself. There's a certain order that we go in though. So I actually have to get rid of the 5 first. So think of it this way, always get rid of what's farthest from the x first. The 2 is like smushed right up against it, and the 5 is farther away, so you're going to get rid of that first. Right, it's separated by a plus sign. So what's the opposite of adding 5? Good, opposite would be to subtract it. And then we get 2x equal to what's 0 minus 5? -5. Now we have 2 times x. What would be the opposite of multiplying by 2? Dividing by 2 would be opposite. And you have to do it to both sides. So then my x value becomes, or my other x value becomes -5/2. All right, you could make it a decimal, but fractions are more exact. All right, so -5/2 and 1 are my answers. And I'll write them over here. Any questions? All right, I don't want to take up more time, so I want to give you time to at least try it yourself with the practice worksheets. I'm here if you need help. I'll be walking around, or you can meet me at the back table and I'll help you a little more. All right, but you have the day 1 practice and the day 2 practice, just the evens or odds. Don't overwork yourself. Just the evens or odds will give you enough practice. The answer keys are on this back wall so that you can check your work as you go. And then upload it to Schoology when you are finished. Question, Matthew? From the day 1 practice that you guys might have questions on as well. So this is from the day 1. If you want to copy this one on. I'll even, if you're doing evens, you can do this one in place of 14, that's fine. But for number 13, how can I factor this? Like, what method will I use? There's 2 terms, so I can't use diamond, I can't use slide and divide. I can check if it's a difference of squares, but it's not, because there's a plus sign.
On the GCF.
Good. So I'll factor this one with GCF. What is the GCF? X. Right? The 1 is 3, the GCF would be 1, and we don't really care if the GCF is 1. So then you check the variables. We can factor out 1x from each term. So divide your GCF from each term. Put your GCF on the outside of your parentheses. What's x squared divided by x? Sorry, I don't know what that was about. And what's 3x divided by x? All right, 3x divided by x is 3. And it's positive. All right, let me hold your attention for just a little longer. Now we need to set each factor equal to 0. How many factors do I have?
Or 2.
I have 2. So factors are things you multiply together. It's x times these parentheses. So set them equal to 0, x equals to 0, and x plus 3 equals to 0, and solve for x. All right, over here, x is already by itself, so that's going to be part of my answer. Over here, we solve for x, so subtract 3 from each side, and we get x equals -3. All right, so there's 2 answers, not just 1. Questions about that? All right, so that's from your practice if you want to copy that one down. And then you guys can continue.